by subtracting integers, our lesson. This is going to be just a two-part lesson. We're going to do the first part today, and then we're going to continue on and practice more tomorrow and spending more and more time there. Right now, we're going to have you guys start with just a connection to what this is really, another concept that really makes sense in this. So go ahead and pause the video, pull out your just a random sheet of paper, or use the whiteboard and solve these 4 problems. Okay. All right, when you're ready, you can start the video again and see what you come up with. All right, so this first one, we rewrite it as 4/9 times 5/3, and you end up getting 20 over 27. No simplification required. Next one, we're going to go ahead and keep doing this one. This one's going to end up being 13 over 16 times 1/9. Ends up getting 13 over 144. We work on our next one. This one I kind of like because it's going to let me cross reduce 4/7 times 1/8. Cross reduce down to 2 and 1. Okay, so we get 1/14. And then finally, our last one, we're going to go ahead and say, all right, there's actually something we can do before we even bother flipping it. We can reduce these down to 3/4 and 1/3. Now we do our keep change flip. 3/4 times 3 over 1 equals 9/4, which would simplify to 2 and 1/4. All right, so you kind of see how those are. This idea of keep, change, flip is going to lead us to our idea today. So we'll see where that ties in later today. So like I said, we're going to be working on subtracting integers. This is a different kind of concept because I've got to help rewire your brain a little bit. I've got to change your number system. When we change our number system to integers, different rules start to apply. You've been using addition and subtraction since you were in kindergarten, but now we're really going to take a look at it in a different number system. You've been mainly working in the whole number system, or at least the positive side of the rational number system as you got through the older grades. But now we're going to take a look at the negative side, the whole other half of the integer number system and rational number system. So, little refresher from yesterday's lesson. So yesterday we went ahead and you guys did this. You guys learned a couple of things. So the first thing we learned was that if you have the same signs, you're going to add and keep the sign. So this one equals -28. If you have different signs, you're going to subtract and keep the one with the greater absolute value. So this one ends up being 3. Here the greater absolute value is 19, so you're going to be -2. Same signs again, so now even though they're rational numbers, now we can follow the same rules. It's 13 and 22/100. We learned yesterday that this negative actually goes up here with the numerator. So different signs we're going to subtract, so it's going to be 4/7 and 6/7 is the greater absolute value. And finally, the last little piece, this kind of brings back in lesson 1 and now adding into 2. What does the absolute value sign mean? Exactly, it says it's the distance from 0. So it's going to be +4, and then we have different signs. With 13 being the greater absolute value, the answer is -9. So we've got a little review, a little refresher. You got to keep that in mind. So let's jump in. So that's the same thing we came up with on this one. So when we have the same signs, you're going to add and keep the sign, as we practiced yesterday. When you have different signs, you're going to subtract and keep the sign of the number with the greater absolute value. Now, that's addition. Now let's take a look at subtraction for a second. We're going to start on a number line. So yesterday, I'm going to kind of tie into yesterday. We did 3, a plus, a -5. I'll really quickly sketch out a number line for us. And we talked about yesterday, there's my 0. Anytime you have a positive number, we go to the right. So we start at +3 right here. That's our first number. And then when we see this, it really just means the word left. Left 5. So 1, 2, 3, 4, 5. That brings us back here to -2. And that's the same thing we learned when we did it the other way, is we keep the sign, we subtract 5 minus 3, keep the sign of the greater absolute value, and that's how we got our -2. So now that we've kind of talked about left and positive being right, we're going to take a look at it with subtraction. I'll keep the same numbers. 3 minus -5. Just change my sign in the middle. So I've got that same number line. And let's think about what we've got here. I'll put 0 right here. So again, we're starting at 3. So there's my first number. This means left. This means left. So when I go 2 lefts, you go left, left, we're going to end up pointing the opposite direction. If I'm starting going this way, 90 degrees, so it's 1 left. Here's my last left. I'm going the opposite direction. So I want you to think of the opposite direction of negative is positive. So this is going to actually turn into 3 plus 5. So we're actually going to go to the right 5 steps, and that being 8. There's my final answer. It's a little tricky. It's kind of like language arts, though. You've been taught for a long time you can't use double negatives because you're really saying it's positive. Hey, guess what? This is the mathematical version of double negatives. If I'm not going somewhere, that means I am going somewhere. If I'm going left, I'm actually going to end up going the opposite direction. So if you think of the opposite of negative as being opposite of left on a number line is right on a number line, when I turn around those 2 times like this, that's how I get back there. And we touch more on this in class, and if you're stuck on it, please reach out and talk to me. So there's a rule that kind of helps us figure that out. These are our addition rules. We're talk subtraction rules. And remember how we talked about keep, change, flip as the precursor to this? The subtraction rule is K, keep, change, opposite. So it's that same rule. Get my writing correct. Opposite. Okay, so what I mean by that is I'm going to keep my first number. So just like we did a moment ago, we had 3 minus negative 5. We're going to keep that first number. There's my keep. We're going to change to positive, so 3 plus, and then take the opposite of negative 5. The opposite of negative 5 being 5. And then we're going to follow the addition rules. In this case, it's same signs. So let's try. Another way to look at it is right here. Keep, change, change. Another way to think of it is just 2 different ways to think the same way. I like keep, change, op. It just helps me remember that it's 3 different things. It helps me kind of keep that in mind, the opposite of a number. And that's what really is the key to this problem, is learning how to pull this together. One of the ways I want you guys to think about it is the reason subtraction doesn't work. If you think back all the properties you've learned throughout your years in school, subtraction has never had a property for it. There's always been the additive property of equalities. We've had the additive inverse. We've had associative. We have commutative. Those have all been dealing with addition. It's because subtraction can be rewritten as addition, and the property applies to addition then. So all those old rules where your teachers told you it didn't apply to subtraction, it didn't in the whole number system or in the natural number system. But in the integer number system, using negative numbers instead of subtraction, everything applies because you're going to switch everything to addition and be able to rearrange everything. It's the same reason you were kind of doing it yesterday. I don't know if you guys noticed when you're doing the subtraction, you're switching the numbers around. It's because you're really working with negative numbers. So let's practice a couple. So if we take a look at this one, 4 minus 3, we're going to follow our keep, change, op. 4, switch to positive, take the opposite of 3. So now we follow our addition rules. Greater opposite values 4. 4 minus 3 is 1. Same here. Keep, change, op, it's negative 15. Okay, so greater opposite value here, 15 minus 8 is negative 7. Same here. So as we keep working our way through it, keep negative 5, change to addition, opposite of 9 is negative 9, giving me a negative 14. Okay, and then this one is a little different looking. Negative 10, so it's still keep. Change it to addition. The opposite of negative 4 is positive 4. So I have my opposite signs. 10 minus 4 is going to be 6. The greater opposite value makes it negative. All right, and the last one that we're going to do, and then I'm going to have you practice the other 3, is the same idea. Keep the 16, change it to positive. The opposite of 14 is positive 14. This time the answer is 30. Okay? Take a moment and try these 3 problems. Pause the video and see what you come up with. Now that you've had a chance to do it, you get negative 12, negative 7.8, plus 1.9. You end up getting negative 5.9. And again, same here. We keep that negative up there. 7 eighths plus 3 eighths gives you 10 eighths, which would simplify to 1 1/4. All right. And last thing we take a look at is the word problems. What we're really working with, it's 71 minus 52. So there's no subtraction, so we're going to follow our keep, change, op. 71 plus a negative 52. That means the stock price rose $19. And the last one, go ahead and We'll take a break. You guys can try these, and we'll talk about them some more in class as we go. All right. If you have questions, please, as always, feel free to reach out to me, and we will help you make sure you understand this.